Hey, Kelsey. We were a couple problems into the notes before I realized that I forgot to hit record. So I'm going to go ahead and record this for you. I left all of my work on each one of these problems, so it'll take me a little less time to kind of explain things to you. But if you need to pause at any point during this while I'm explaining this to you, go ahead and do that. We started with example 3. And what we did here is we were trying to determine whether 2x squared plus 1 is a factor of this longer function here, okay? And so we did that by long division, and we have to use long division because it's x squared. We can't use synthetic division, okay? So we went ahead and divided it out, and the only thing that I kind of cautioned them on was that even though we didn't have to add any zeros into this function here because it went x cubed, x squared, x, and then number. Since it goes 2x squared plus 1 and there's no 0x squared, 0x in there, we have to add that 0x in when we list it off over here, okay? So we went ahead and did our long division. And we ended up getting x minus 2, but at the end we got 0 as a remainder. And so what that means is that since we got 0 as a remainder, he is a factor. This 2x squared plus 1 is a perfect factor of the 6x cubed minus 4x squared plus 3x minus 2. That means he goes in there perfectly, so yes, 2x squared plus 1 is a factor. Because he has 0 as a remainder, that means he goes in there perfectly, so he is a factor, okay? All right, if you need to pause that to get the rest of that work in there, you sure can. And if you need me to explain the long division problem to you, I sure can do that. But there's that example, okay? The remainder theorem is the next thing that they talk about. And if we look at example 4, I'll kind of explain to you how this works, okay? Find the remainder when we're taking this thing and we're dividing by x minus 1, okay? All right, this would be a really, really, really ugly problem if I would divide it out using long or even synthetic division. What I would have to do is I would start with x to the 79th power, but then I would have to put plus 0x to the 78th, plus 0x to the 77, 76, 75, 74, and then when I would get to the 24th power all the way down there, I would put plus 3x to the 24th power, and then I'd have to do 23, 22, 21, all the way down, and I'd have something that was 79 values long, and I'm using that, and I'm dividing by x minus 1, okay? Really ugly. But what they have found is that if I am dividing by x minus 1, what I can do is kind of like when I set up synthetic division, I would set that equal to 0 and x would be equal to 1. What I can do then is I can set that equal to 0, x equals 1, and I can plug 1 in for x into this function, and whatever it comes out to be will give me what the remainder will be, okay? So I plugged 1 in there, and I got 1 to the 79th power plus 3 times 1 to the 24th power plus 5. Okay, well, 1 to the 79th power is 1. 1 to the 24th power is 1, but then I take that times 3, and I get 3. And then plus 5, and I get 9. And what that means is that if I take this function here and I divide by x minus 1, 9 will be my remainder, okay? So we said that this is a really good way of checking your answer, okay? So up here in this example, when we did synthetic division, okay, I divided everything all out. I got to the very end, and I found out that my remainder was 8, okay? Well, what I could do is when we're dividing by x plus 3, okay, I set that equal to 0, and I get negative 3, and what I can do is I can plug negative 3 into this big long function here, which we did over here on this side. And what I found is that after I plug that negative 3 in and I solve for it, I got 8 as the answer. So what I can do is I can check that and make sure that since I got 8 over here when I plugged it in, 8 should be my remainder. And in fact, when I did my synthetic division, 8 was my remainder, so I know that I did that division right, okay? So that's just kind of a way of checking your answer to see if you did it right. That should always be the case. Now, the problem with that is kind of like when, You can't always do synthetic division. Like for this problem down here, we couldn't use synthetic division when we're dividing by 2x squared plus 1. You can't use the remainder theorem to check 2x squared plus 1 because, you know, I can't find a value and set it equal to 0 and then plug that thing in when it's not just a linear factor. Okay, so example 5, we did that same thing again. We said if we're dividing by x plus 2, we would set it equal to 0 and we get -2, and we would plug that -2 into this function, and I got -5, okay? So that would be what my remainder would be if I was dividing that out, and then we can use that to draw some conclusions, and we say, okay, if -5 was my remainder, would x plus 2 be a perfect factor and go in there evenly? No, it wouldn't be, because it has to come out to be 0 if it's a factor, okay? So that's what this next bubble says, is that it's only a factor if your remainder comes out to be 0, which kind of makes sense, okay? So down here, show that x minus 3 is a factor of this guy. So we did that first by setting that equal to 0, so that means I'm plugging in a positive 3 into this function, and when I plug in a positive 3, I get 0 as my answer. And then it says find q of x so that x minus 3 times that q of x gives me this function. Or in other words, to get q of x, I'm just dividing by x minus 3. So we chose to do synthetic division to divide that out. So set the 3 up, and I did my synthetic division, and what we noticed was that my remainder was 0, just like it was supposed to be. When I plugged it in, I got 0, which means my remainder should be 0. Okay, and so we were taking something like x cubed, and I was dividing by an x, so this first number here should be an x squared, second number should have an x on it, the last number is just my number, and what it looks like is something that looks like that, okay? So if I take this function and divide by x minus 3, this is what's left over, okay? All right, the next example. We kind of skipped over this example, but one thing that I addressed on here was they asked for A, B, C, and D. They asked for the x-intercepts, the zeros, the solutions, and the linear factors, okay? When it asks for that, it looks like we're having to do a whole lot of stuff on A through D, but x-intercepts, zeros, solutions, and linear factors, as well as roots, if they would have asked for the roots as well, all of those things mean the same thing. X-intercepts, zeros, solutions, roots, factors, all of them are finding the same thing. They're all finding the x-intercepts. And to do that, we would set the y-coordinate equal to 0. So I just plug 0 in for the y-coordinate, or in that case, it was f of x. We plug 0 in there, and then we would solve, okay? So we didn't go ahead and break that down and solve and do any division or anything like that, but I just kind of wanted to throw that out there, that if they ask for any of those things, they all mean the same thing. Okay, we went down and we solved out example 8, and what it tells us is it says find 3 polynomials. I just said let's find the one polynomial because that's a pretty long process just to find one of them, so we just found one. Find one polynomial that has zeros that are 1, 2, 3, and -5, okay? So what that means is that x equals 1, x equals 2, x equals 3, and x equals -5, okay? And before we went any further, I said, okay, let's do this as an example, okay? Here's my example. Let's say I had x squared plus 9x plus 14, and they asked me to break that thing down. That thing is a simple trinomial, so I'm looking at what can I multiply to get 14, but when I add them, give me 9, and that would be 7 and 2, okay? And then when I find my answer, I set them equal to 0, and x equals -7, and x equals -2, okay? What they're asking us to do is work backwards. So they're giving me the answer here, 1, 2, 3, and -5, and they're wanting me to find what that polynomial looks like. Okay, so we work backwards and we say x equals -7, x equals -2. That means inside of parentheses it would be x plus 7 and x plus 2. Okay, so here if I have 1 and 2, that means x minus 1, x minus 2. Here it would be x minus 3, and since it was a -5, that would be x plus 5. And then to find my polynomial, I would just multiply and FOIL each one of them out, okay? So we kind of decided that the fastest way to do that would be to take these two and multiply them together and FOIL them out. Whoop. And then take these two and multiply them together and FOIL them out, and then take those two answers and multiply those together to get our final answer, okay? So when we FOILed that out, we got 4 pieces, but then we said combine those middle 2 pieces to get -3x in the middle. 4 answers over here, 4 pieces over here, and then combine those middle 2 pieces to get 2x. So really, in the end, I only have a trinomial times another trinomial, okay, which still is going to give me 9 pieces, and that's these 9 pieces right here, okay. And when I do those 9 pieces and I combine like terms, I get this as my final answer, okay. And the one thing that I said to notice was they gave me 4 different numbers here to multiply together, which means that my polynomial is going to be x to the 4th power. So this has 4 zeros because he is a 4th degree function, okay? And that kind of makes sense, I guess. 4 x's multiplied together is going to give me x to the 4th power, okay? So that was kind of that long process multiplying all those together, all right? And then the last example was a really short one. It says state the maximum number of zeros that this polynomial is going to have. He is an x to the 4th power function, which is his highest power. So that means he can have 4 zeros. So if I would break him down, we'd have 4 answers, just like example 8 would, okay? So if you need to go back through any of that to write any of that down, go for it. Hopefully that kind of got you the gist of what we were going through. I will tell you on Monday, what I told the kids is that, some of these problems take a while to do. The long division, synthetic division, they are kind of long problems. So I'm going to give you guys a work day on Monday. So I'll give you time to work in class to do this homework assignment, and then Tuesday is when we'll start section 4-2. So there you go.